Hello and welcome. If you find something restful in long, unhurried journeys through the physics of deep space, consider liking and subscribing Minus. It helps this quiet corner of the universe keep growing. Before you settle in, tell me where you are listening from tonight. A room lit by a single lamp, a sofa with the curtains drawn against the cold, a garden holding the last of the evening air. Somewhere the world has already gone very still. Wherever you are, the light now touching your screen left the surface of the sun 8 minutes and 20 seconds ago. It feels instantaneous. But by the universe's own measure, it is heartbreakingly slow. Why can nothing move faster? What is waiting 4 light years from here? How far is too far to ever truly cross? And why, in a cosmos of 2 trillion galaxies, is there only silence around us? On the Christmas Eve of 2024, humanity reached its greatest ever speed, the fastest any object we have ever built has moved. And it would still need more than 6,000 years to reach the nearest star. That is tonight's subject. You do not need to hold every word. Let the distances carry you, and simply rest. Let us sit with that Christmas Eve machine for a moment, because it is a good place to begin. Its name is the Parker Solar Probe, and on that night it swung close to the sun and reached a little over 192 kilometers in a single second. In the older, more familiar units, that is roughly 692,000 kilometers in an hour, misers fast enough to cross from one coast of a continent to the other in well under a minute, fast enough to circle the entire Earth in only a few minutes. No human hand has ever thrown anything so quickly. And yet, and this is the first gentle strangeness of the night, that record-breaking speed is only 64 thousandths of a single % of the speed of light. Not 1%. Not a tenth of a percent. A small sliver of a single hundredth of a percent. Because light, you see, is the true measure here, and light is almost unimaginably quick. It moves at very nearly 300 million meters in every second so reliably, so exactly, that since 1983 we no longer even trouble to measure it. We define it. The meter itself is now built from the speed of light rather than the other way around. Light is not simply fast in our world. Light is the ceiling of the world. And so here is the quiet paradox we will turn over together tonight. That ceiling, that fastest of all possible things, needs 4¼ years merely to reach Proxima Centauri, the nearest star beyond our own sun Linus, a neighbour some 40 trillion kilometres off, close enough that we call it close, far enough that light itself arrives years late. Our patient Voyager probes, still coasting outward since 1977, would need more than 73,000 years to make that same short trip, more than 2,500 human generations, born and gone and forgotten, before arrival. And this, remember, is only the nearest star. Only the first doorstep of a galaxy 100,000 light years wide. So the thing worth carrying into sleep is not that space is large. Everyone already knows that space is large. It is the oldest and dullest fact we have about the sky. What we are turning over tonight is something stranger and softer. It is that the very fastest thing that exists, the fleetest messenger the universe permits, is measured against the distances between the stars, achingly, almost tenderly slow. And that this single quiet limit, written into the fabric of things long before there was anyone to notice it, may be the real reason the night answers us with such deep and patient silence. You do not need to solve any of that. Let it simply sit there, unhurried like a stone at the bottom of clear water. We will unfold it slowly, gently, from the ground up mises, beginning not with distant galaxies at all, but with the smallest and nearest thing of all, the ordinary light already filling the room around you, and only then working our way outward, step by step, into the dark. So let us begin exactly where we promised, with the light that is nearest to you, not a distant star, not a galaxy whose name you will forget by morning, but the ordinary light already in the room. Perhaps it is the pale grey of a window that has not quite gone dark. Perhaps it is the small glow of a screen you have not entirely set down. Perhaps it is only a thin blade of brightness slipping under the door from some other still-lit corner of the house. Wherever it comes from, notice how it behaves. It does not seem to arrive. It is simply there, filling the space around you the moment there is anything to fill it, with no gap you could ever hope to catch, no pause between the striking of the match and the seeing of the flame. You flick a switch, and the room is bright in the very same instant. And so the first and most natural belief any of us has ever held about light is this quiet one, that light does not travel at all, that it does not go from here to there, that it simply is. That belief is not foolish. It may be the most reasonable mistake a thinking creature has ever made. For everything else in your experience takes time. A thrown ball arcs slowly across a garden. A sound rolls in after the lightning, late and low. Even a fast runner, even a galloping horse, even the swiftest bird you have ever watched cross a field, all of them can be seen to move, to depart from one place, and to reach another after some measurable while. But light refuses to show you the journey. And when a thing seems to arrive everywhere at once, the honest conclusion, the conclusion your own eyes press upon you, is that it never really went anywhere. It was here all along, waiting only to be released. The great minds of the ancient world thought so too. More than 2,000 years ago in Athens, the philosopher Aristotle set the question down plainly and answered it with confidence. Light, he argued, was not a thing that moved from place to place, but a condition, a kind of presence that the whole of the transparent air fell into together, the way a stillness settles over a room when everyone in it stops speaking at once. To him, the very suggestion that light might take some time to cross a distance was close to absurd. What, after all, could possibly be quick enough to outrun our own looking? And so, not by carelessness, but by careful reasoning, the settled teaching of the West became that light is instantaneous. It filled the mind of Europe for a very long time. Century followed century, and almost no one thought to doubt it. Almost no one. But there is nearly always someone, somewhere, quietly unconvinced. Around the year 1000, far from Athens, in the libraries and the lamplit studies of Cairo, a scholar named Ibn al-Haytham began to turn the question over again from the beginning. In the West, much later, he would come to be called Al-Hazan, and he is remembered now as one of the first true students of light there ever was. He did not accept the old picture that the eye reaches out to touch the world. He argued instead that light travels the other way, that it streams from every glowing thing and pours off the surface of every ordinary object, and only then enters the eye to be seen. And once you believe that light travels, that it genuinely crosses the space between a candle and a face, a further thought becomes almost impossible to avoid. If light goes from one place to another, then surely, however fast it may be, it must take some amount of time to get there. As the account is usually told, Al-Haytham came to just that conclusion. Light, he reasoned, does not arrive in no time at all. Its speed is not infinite but merely enormous, so vast that our slow senses can never hope to notice the delay. It was a beautiful guess, and it was correct, and there was no possible way in his century to prove it. That is the quiet tragedy that hangs over so much early science. The right answer is reached long before there is any instrument fine enough to confirm it, and so the idea waited, as ideas do, patient and unhurried, for the world to catch up. It waited some 600 years. Then, on the hills above Florence, an old man tried to trap the light with lanterns. Galileo Galilei, near the end of a long and difficult life, described an experiment as simple as it was hopeful. 2 people, each standing on a distant hill in the dark, each holding a lantern with a shutter that could be opened and closed by hand. The first man uncovers his light. The instant the second man sees that glow, he uncovers his own in reply. And Galileo's thought was this: if light takes any time at all to cross the valley between the 2 hills and to come back again, then there ought to be some small, measurable pause between the moment the first shutter opens and the moment its owner sees the answering flash return. He set it all down in the last book he ever wrote, in the 1630s, when he was nearly blind and confined to his house. But no matter how far apart he placed the lanterns, no matter how carefully the 2 men worked, the reply always seemed to come back the very instant it was called for. He could find no delay. And so, with the honesty that is the real mark of a scientist, Galileo did not claim victory. He concluded only what his failure allowed him to conclude, that light, if it moves at all, moves extraordinarily fast, faster than any experiment he could ever build could hope to catch. Not proven, but suspected, not measured, but glimpsed. The lanterns were simply too close together, and the light too swift, and the whole of the Tuscan countryside far too small a stage on which to catch so fleet a thing in the act of moving. The mistake, you see, was one of scale. It has been the great recurring mistake in this entire story, and it will return again tonight, larger each time. To measure something so quick, you cannot use 2 hills. You need a track long enough and empty enough that even a runner as fast as light might take a moment you could actually notice to cross it. And the first person ever to find such a track did not go looking for one on the earth at all. He found it in the sky. His name was Ole Romer, a young Danish astronomer, and in the year 1676 he was working at the Royal Observatory in Paris, keeping patient watch not over light itself, but over a moon. The moon was Io, the innermost of the 4 great moons that circle the planet Jupiter, and Io does something wonderfully regular. On each loop around its giant world, it swings behind the planet and vanishes into Jupiter's enormous shadow, and then, a while later, it slips back out into the sunlight again. These little eclipses happen like the ticking of a distant clock, over and over, at intervals that ought to be perfectly predictable. Astronomers had been timing them for years, hoping to use them as a kind of celestial timepiece. But there was a stubborn flaw in the clock that no one could explain. It would not keep steady time. Rumour noticed the pattern in the flaw. When the Earth, on its own yearly journey around the Sun, was swinging close to Jupiter, the eclipses of Io arrived early, ahead of schedule. And when the Earth was drawing away to the far side of its orbit, so that a vast additional gulf of empty space lay between us and Jupiter, those same eclipses fell later and later behind, running slow by many minutes together, a quarter of an hour and more. The moon itself was not misbehaving. Io was as faithful as ever, ducking into shadow on time, every time. What was changing was not the event, but the distance the news of it had to travel to reach a watching eye in Paris. When the Earth was near, the light-carrying word of the eclipse had a shorter road to run, and so it came early. When the Earth was far, that same light had to cross the whole extra width of our orbit before it could arrive, and so it came late. The delay was not a fault in the heavens. The delay was the travel time of light itself, made visible at last, written across the solar system on a scale finally large enough to read. This was the proof. Not a suspicion, not a beautiful guess left hanging for centuries, but a genuine demonstration that light has a finite speed, that it takes real time to cross real space, and that the ancient certainty of instantaneous vision had been quietly wrong all along. Römer put a number to it, the first honest number anyone had ever managed. And his number, it must be said, was not quite right. It ran a good deal long, for his measurements of the sky were rough, and the size of the Earth's orbit was itself only loosely known. But being a little wrong hardly mattered. Nobody remembers Römer for the exact figure. They remember him because he was the one who proved that there is a figure at all, that the swiftest messenger in the universe is not infinitely swift, that even light must wait upon the distances it crosses. And once you know a thing has a speed, the only question left is how, and how precisely, you might pin that speed down. It would take another 2 centuries and a handful of extraordinarily patient minds to close the gap between Römer's rough first guess and the exact value we hold today. Consider Hippolyte Fizeau, a Frenchman working just outside Paris in the year 1849. Römer had caught light in the great clockwork of the heavens, borrowing the moons of Jupiter as his ruler, and there was something magnificent in that, and also something faintly impractical, for you cannot exactly repeat such a thing on a whim. Fizeau wanted the measurements smaller. He wanted a thing he could hold in his hands and try again on any clear evening. So he built a wheel, not an ordinary wheel, but one edged with hundreds of fine teeth, cut like the teeth of a comb, and he set it spinning. He sent a thin beam of light out through a single gap between 2 teeth, across the rooftops to a distant mirror roughly 8.5 kilometers away, and then let it come racing back. When the wheel turned slowly, the returning light slipped home through the very gap it had left by. But as he spun the wheel faster, there came a precise moment when a tooth had rotated exactly into the path by the time the light returned, so that the beam was blocked, and the far mirror seemed to go dark. From the speed of that turning and the distance to the mirror, he could reckon how long the light had been away. He had measured the speed of light without once looking at the sky. The whole vast cosmos of Römer's method had been quietly folded down onto a hillside outside a single French city, and still the number would not sit still. It trembled and was refined a little with each passing decade, as ever cleverer machines were built to chase it down. But somewhere in the middle of all this careful measuring, a stranger and deeper revelation was taking shape, and it arrived not from a telescope and not from a spinning wheel, but from a page of pure mathematics. In the year 1865, a Scottish physicist named James Clerk Maxwell was working through the newly understood laws of electricity and magnetism, the silent pull of a magnet, the crackle of a gathered charge, the way a moving current will nudge a compass needle for no reason the eye can see. He gathered all these scattered behaviors into a small and elegant set of equations. And when he asked those equations what would happen if an electric field and a magnetic field kept trading places, each rising as the other fell, each lifting the other onward, they answered that such a disturbance would not stay put. It would travel. It would ripple outward through empty space as a wave. And the equations even told him how fast that wave would go. When Maxwell worked the number through, he must have felt the floor tilt gently beneath him, for it was not close to the speed of light. It was the speed of light exactly, the very same figure the measurers had been chasing across their hillsides. And so light was revealed to be not a substance, and not a fluid, and not some special glowing stuff of its own. Light was electricity and magnetism, braided together, walking hand in hand across the dark. That single recognition changed the whole question, and yet it did not end the patient labour of measurement, and here the story crosses an ocean, to an American naval officer named Albert Michelson. Beginning around the year 1879, Michelson took up a method built around a rotating mirror, and he pursued it with a devotion that would fill the rest of his life. He would cast a beam across a great distance to a far mirror, and back onto a mirror spinning at tremendous speed, and from the faint sideways tilt of the returning light, a shift no wider than a hair, born of how far the mirror had turned in the meantime, he could read the delay, and from the delay, the speed. Where Fizeau had reached across a few kilometres of suburb, Michelson would in time stretch his beams through the open air between mountaintops in Southern California, refining and refining again, shaving the uncertainty thinner year upon year, until his figure agreed with the true value to a precision that would have looked like sorcery to Roma. He gave decades to a single number, and that perhaps is the quiet heroism folded into this whole long story, that a human being could spend the better part of a lifetime pinning down one constant of nature and count every hour of it well spent. By now the number was known with real confidence. But its deepest meaning was still hidden, and it took a young clerk in a Swiss patent office to draw that meaning out into the light. In the year 1905, Albert Einstein, then quietly examining other men's inventions in the city of Bern, published the work we now call special relativity. He did not so much measure the speed of light as crown it. He lifted it up from a mere fact about a particular kind of wave into a law binding the whole of reality. And he proposed something that sounds, on first hearing, almost like a joke, that this speed is the same for everyone, always, no matter how they themselves are moving. Run after a beam of light as fast as you please, and it still flees from you at exactly that same rate. Race headlong toward it, and still it meets you at exactly that same rate. The number does not lean your way. It is not a speed you can ever gain a meter on, and from that one stubborn refusal, every strange consequence unfolds, the stretching of time, the shrinking of distance, and the wall of infinite effort that seals the speed away from anything that carries weight. That same law is at work in the small lamp beside you, in the glow reaching your eyes at this very moment. The light warming your skin tonight is obeying, to the letter, the very rule Einstein wrote down. There is one last step in this long march, and it is the strangest of them all, because it is the moment the number stopped being something we measure and quietly became something we decide. For centuries every figure had been a best guess, a value read carefully off an instrument, forever carrying its little fringe of doubt. But by the year 1983, the speed of light was known so exactly and stood so firmly beneath the whole of physics that the world's keepers of measurement did a remarkable thing. They turned the question inside out. Rather than measuring how far light travels in a second, they declared the speed of light to be exact, fixed for all time, and then used it to define the meter itself. Ever since that year, a meter is simply the distance light crosses in one small, precisely stated sliver of a second, 1 part in 299,792,458 of it. The ruler now bows to the light, and not the light to the ruler. And so we arrive, after 2,000 years of guessing and grinding and squinting up at the heavens, at the plain and settled truth of it. Light moves 299,792,458 meters in every single second, like near enough 300,000 kilometers, or 186,000 miles, in less time than it has taken you to breathe. It is the fastest that anything can ever, anywhere, go. And here is the crushing truth upon which the whole of this night now turns, that dizzying, blistering, unimaginable speed-nighness, the very swiftest thing the universe will permit, is, when you hold it up against the size of the universe itself, agonizingly, heart-breakingly slow. And so a small and entirely reasonable objection may be forming in you now, there in the dark, the very same objection almost everyone forms the first time they are handed this number. If light is only fast, you might think, and not truly infinite, then surely reaching its speed, or slipping past it, is nothing more than a matter of patience and cleverness. We have always done this. We were once creatures who could not outrun a horse, and then we built the horseless carriage, and then the aeroplane, and then the rocket, and each time the ceiling that our grandparents believed was fixed turned out to be only a floor we had not yet learnt to stand upon. Why should this be any different? Why should there be one speed out of all the speeds in the world that no amount of engineering will ever let us beat? It is a good question. It is, in fact, the exact question a young man was quietly turning over in his mind more than a century ago, in a modest office in the Swiss city of Bern, in the year 1905. He was not a famous professor. He was a clerk, a technical examiner in the patent office, reviewing other people's inventions by day and thinking his own long thoughts in the margins of the hours. His name was Albert Einstein, and in that single year a year historians of science now simply call his miraculous one Meisness. He wrote down an idea so gentle in its assumptions and so violent in its consequences that it rearranged the shape of reality itself. He began, as the best thinkers so often do, not with something complicated, but with something almost embarrassingly simple. He asked what would happen if you took just two modest ideas entirely seriously and refused to let go of either one. The first idea was this, that the laws of physics should look the same to everyone who is moving smoothly and steadily, whether you are sitting still in a chair or gliding along in a train that never speeds up or slows down. There is no special, privileged place in the universe from which everything is measured. Your quiet bedroom tonight is as good a laboratory as any observatory on any mountain. That much feels comfortable, even obvious. But the second idea is where the ground begins to tilt beneath you. Einstein proposed that the speed of light is the same for every single observer, no matter how fast that observer is moving, and no matter whether they are racing toward the light or fleeing away from it. And you must sit with that for a moment, slowly, because it defies everything your body has ever learned about the world. If you are walking forward along the aisle of a moving train, then to someone standing on the platform, your speed and the train's speed simply add together. This is the plain arithmetic of motion, and you have felt its truth your whole life. Yet light, Einstein said, refuses to play this game. Shine a beam ahead of you while you yourself are hurtling forward at a fantastic pace, and you will measure that beam pulling away from you at the very same speed as always. Chase after a beam of light as hard as you possibly can, and it will still flee from you at precisely that same unchanging pace, 299,792,458 meters in every second, not one sliver slower for all your effort. The light does not care how fast you are going. It grants everyone the same answer. Now, something has to give. If the speed of light is truly the one fixed thing that everyone agrees upon, then the things we had always thought were fixed, the length of a meter, the ticking of a second, the very idea of two events happening at the same moment, these must be the things that bend instead. And bend they do. This is the quiet, shocking heart of what became known as special relativity, that space and time are not the rigid, indifferent stage upon which the universe performs, but are themselves flexible, stretching and compressing depending on how fast you move, all of it conspiring to keep that one number, the speed of light, forever the same for every witness in the cosmos. But let us come back, gently, to your objection to the dream of simply building a faster ship, because it is here that relativity closes a door that no key will ever open. As you push an object faster and faster, feeding it more and more energy, something strange begins to happen to it. It grows harder and harder to push. Its resistance to being accelerated, the very stubbornness we call mass, the same stubbornness you feel when you try to shove a heavy cabinet across a floor, minus that resistance swells without limit as the object approaches the speed of light. The closer you creep toward that final speed, the more energy each additional sliver of acceleration demands, and the returns grow smaller and the cost grows crueler, until the arithmetic runs away from you entirely. To actually reach the speed of light, an object with any mass at all would require not a great deal of energy, not an unthinkable amount of energy, but an infinite amount. All the energy of every star in every galaxy would not be enough. The universe does not merely make it difficult, it makes it impossible. And this is the point I want to lay down softly beside you, because it changes the whole complexion of the night. The barrier is not a problem of engineering. It is not a wall we are waiting to knock down with a cleverer rocket, or a brighter idea, or another century of patient invention. It is written into the deepest grammar of physics itself. You could hand humanity 1,000 more years, and 10,000 times its wealth, and every genius who will ever be born, and the answer would not move by a hair. The speed of light is not a record waiting to be broken. It is the shape of the road itself. Consider, for a moment, the smallest imaginable traveller, a single electron, one of the tiny particles that at this very instant are streaming through the wires in the walls around you, lighting the world and carrying every message. An electron weighs almost nothing at all. It is among the lightest specks of matter we know. And yet even that near nothing if you wished to accelerate it to precisely the speed of light, would demand an infinite amount of energy to do so. If the universe will not grant this passage even to the humblest flick of a particle, what hope is there for a ship, for a crew, for a fragile, warm body like yours, made of uncountable trillions of such particles bound together? You can feel the whisper of this law in your own flesh, right now, without any instrument at all. Think of the last time you were carried in a car that suddenly gathered speed, and how you felt yourself pressed back into the seat, your body reluctant, lagging, wanting to stay where it was. That gentle push against your spine is inertia matter's quiet insistence on keeping its state of motion. It is a small, everyday thing, but relativity tells us that this same reluctance, this same stubbornness, does not stay small. Wind the speed up and up toward the great cosmic limit, and that mild pressure you felt in the car would grow monstrous, unappeasable, infinite. The very substance you are made of would fight you, harder and harder, all the way to a wall that can never be touched. The limit is not out there among the distant stars. It is stitched into the atoms of your own hand resting on the blanket. So how close have we come, we clever apes who built the horseless carriage and the aeroplane and the rocket? How near have our fastest machines crept to this forbidden edge? On the 24th of December, in the year 2024, a small spacecraft named the Parker Solar Probe swept in close to the Sun, and in doing so, became the fastest object human hands have ever made. Slung forward by the Sun's own gravity, it reached a speed of 192.22 kilometers in every second, some 692,000 kilometers in an hour, a pace that would carry it around the entire waste of the Earth in the time it takes to draw a slow breath. It is a genuinely staggering achievement, the swiftest thing our species has ever set in motion, faster than any bullet, any missile, any dream our ancestors ever dared to dream. And here is where the gentleness of the night turns, quietly, into something like awe. For all that blistering speed, the Parker Solar Probe was moving at just 64 thousandths of 1% of the speed of light. Not 64%, not 6%, not even 1%, a little over 600ths of a single percent. If you imagine the full speed of light as the distance from one side of a wide, still lake to the other, then the fastest object humanity has ever built has, in all its glory, pushed off from the shore and travelled about the length of your own outstretched hand across the water. The rest of that vast lake stretches away, unbroken, into the dark, and beyond even the far shore of the lake lies the true subject of this night, the distances between the stars, which do not measure in lakes at all, but in oceans upon oceans that no swimmer, however swift, will ever cross. And to cross even one of those oceans, you would first need some honest sense of how wide it truly is. So let us build that measure slowly, patiently, the way a person half asleep lays one gentle thought upon another until a whole quiet structure stands where a moment ago there was nothing at all. Light, as you already know by now, travels at very nearly 300,000 kilometers in a single second. Give it not a second but a whole year to run an entire year of seconds, never slowing, never resting, never once pausing to gather itself minus, and the distance it sweeps out has a name we have chosen to make sound almost homely. We call it 1 light year, a year of light. It has a soft domestic ring to it, that phrase, as though it were something you might fold and keep in a drawer. But set the poetry gently aside for a moment, and translate that year of light into the plain, patient language of kilometers, and the friendliness quietly drains away. 1 light year is not 1,000 kilometers, and not 1,000,000, and not even a mere billion. 1 light year is roughly 9.46 1 trillion kilometers. 9.5 trillion. A single 9 trailed by so many zeros that the mind simply lets go of them, one after another, the way tired fingers lose their grip on a thread. That is the distance light, the fastest thing there is, the one thing nothing at all can outrun, manages in the course of a single year. And it is only the first rung on a ladder that climbs far, far higher than this. Now hold that 1 light year in your mind, if it will stay, and let us walk it out to the nearest star beyond our own sun. Proxima Centauri sits a little over 4 light years away, 4.25, near enough. In kilometers, that is something close to 40 trillion. 40 trillion kilometers to the very nearest neighbor we have. And here is a way to feel it in the body, rather than merely to hear it spoken. Imagine you could climb into an ordinary car and drive there in a straight line, holding a steady 100 kilometers an hour, the easy pace of a motorway late at night. You never stop for fuel. You never stop to sleep. You simply drive and go on driving. At that speed, the journey to the nearest star would take you not a lifetime, and not 1,000 lifetimes, but somewhere near 46 billion years. That is more than 3 times the entire age of the universe. You could have set out driving before the sun and the earth even existed, kept your foot on the accelerator through the whole long history of everything that has ever happened, and you would still not have arrived, not even close. Let that settle over you gently, without any alarm. It is not a fact meant to frighten. It is only the true size of the room you were born into. And notice, as you lie there, the light itself is not troubled by any of this. The same light that struggles in our human reckoning to cross these distances is also the thing already touching you where you rest. The faint glow in the room, the paleness at the edge of the curtain. When the sun rose this morning, wherever you are, the light that warmed your face did not arrive the instant it left. It set out from the surface of the sun and travelled for 8 minutes and 20 seconds, across roughly 150 million kilometers of empty space, before it ever reached you. You have never once in your whole life seen the sun as it is. You have only ever seen the sun as it was 8 minutes into the past. And that small, ordinary delay, the delay hidden quietly inside a single sunbeam, is the very same limit that seals off the stars. So let us climb the ladder outward, one calm step at a time. To the moon, that light takes only about 1.25 seconds, near enough that a conversation with someone standing there would carry only the faintest, most patient of pauses. To the sun, as we said, 8 minutes and 20 seconds. Out past the great planets, the delay stretches into hours. And if you follow the sun's gravity all the way to its faint outermost edge, to the vast dim shell of icy bodies we call the Oort cloud, the light that left the sun would drift for the better part of 2 years, around 1.87 yearsness, before it slipped across that final boundary and out into the true interstellar dark. Nearly 2 years, and you have still not left home. You have only just reached the farthest fence at the edge of the sun's own quiet garden. Only now, standing at that fence, does the real distance begin. Because from there to Proxima Centauri, light itself nice needing 8 minutes merely to cross to the sun, needing 2 years just to clear the garden ninest, must travel on for more than 4 years further. 4 years and a quarter, at the one speed the universe will never let anything exceed. And this at last is where our proudest machines must be laid quietly against the truth. We spoke of the Parker Solar Probe, the fastest thing our hands have ever made, but most of our craft are slower still, and travel not toward a star but merely outward, into the dark, carrying our first uncertain messages. Consider Voyager 1, launched in the autumn of 1977, when many of the people listening tonight were already alive. It is moving away from us at about 17 kilometers every second, around 60,000 kilometers an hour, a speed that would carry it clean across a country before you finished a single slow breath. It is by any human standard extraordinarily fast. And yet, were it aimed straight at Proxima Centaurinis, which it is not, that little craft would need something on the order of 73,000 years to arrive. 73,000 years. More than 2,500 human generations, born and living and dying one after another, grandparent to grandchild, for the whole length of a single one-way trip to the nearest star. Reach back before Voyager to an earlier machine that flew faster still. In the middle of the 1970s, a small probe called Helios 2 fell close in toward the Sun, and let the Sun's own gravity fling it onward until it was moving at some 240,000 kilometers an hour, quicker even than Voyager. And still, at that speed, the journey to Proxima Centauri would take not a few centuries, and not a few thousand years, but something near 19,000 years, roughly 600 generations. About as much time, give or take, as has passed since the last great ice age loosened its grip upon the world and the first villages began to gather at the edges of the retreating cold. So this is the shape of it, laid down gently, brick upon quiet brick. Our fastest craft, our boldest engines, our most patient dreams measured against the gap to the very nearest star Nizenes, are not a little too slow. They are not almost fast enough, wanting only a better rocket or a braver crew. They are slower than that gulf by a factor so vast that whole civilizations could rise and fall and be wholly forgotten in the time it takes to cross it a single time. And the nearest star, remember, is only the first of them. It is the doorstep. It is the closest lamp in a city of lamps that runs on, and further still, further than any of us has yet dared to count. But perhaps as your thoughts drift, you find some quiet, stubborn part of you beginning to resist a little. Perhaps it wants to protest, softly, that these are old machines, that Helios flew half a century ago now, and Voyager older still, and that surely, in all the patient years between then and this quiet night, we have learnt to do better. Surely somewhere we have built something faster, something swift enough to shrink those hundreds of generations down to a span a tired mind could almost hold. And that stubborn thought is not foolish. It is right, in fact. We have built something faster. There is a machine flying at this very moment, out there in the dark beyond the window, that is the swiftest thing human hands have ever made. Let me tell you about it, slowly, because it is a genuine marvel nation, and because, in the end, it will not save us. It is called the Parker Solar Probe. It is a small, tough craft wrapped in a shield of carbon against a heat that would vaporize almost anything else we own, and it was sent not outward into the cold, but inward, downward, falling toward the sun to touch the outer edges of a star and lived to report what it found. And in the course of that long fall, it did something no object born on Earth had ever done before. On the 24th of December, in the year 2024 minus a Christmas Eve, while much of the world was asleep or gathered quietly indoors, it reached its closest approach to the Sun, and, in doing so, set the all-time record for human speed. Not a little faster than anything before it. Faster than everything before it, by a clear margin, at the very floor of the Sun's gravity well. Consider for a moment how fast. The Parker Solar Probe, at that record instant, was moving at roughly 192 kilometers in a single second. Not in an hour, not in a minute. In 1 second, minus the length of a single unhurried heartbeat as you lie there, it crossed 192 kilometers of empty space. Written the way we usually speak of speed, that is around 692,000 kilometers in an hour. It is something near 430,000 miles an hour. If it held that pace, it could carry you from one side of our whole planet to the other, pole to pole, in about the time it takes to draw a slow breath and let it go. This is the summit of everything we have done. Every rocket that ever rose on a pillar of fire, every gravity assist swung around Venus, and it did swing around Venus, on the 6th of November that same year, borrowing the planet's own motion to fling itself faster still. Every calculation and every welded seam and every sleepless night of every engineer who ever worked the problem, all of it, gathered into a single object at last at its fastest, moving at 192 kilometers each second. And now let us do the gentle, terrible arithmetic, the same way we have done it all night. Let us point that record-breaking machine, the fastest thing our species has ever built, not toward the Sun but outward, toward the nearest star, toward Proxima Centauri, and ask how long the crossing would take. 6,600 years. Sit with that a moment if you are still awake to sit with anything. Not the 70,000 years of Voyager, drifting on its old patient engines, not even the 19,000 of Helios, but 6,600 years. That is what the summit of human speed buys you against the very first star. It is faster, yes. It is far, far faster than anything before it. And it changes almost nothing. To feel the length of 6,600 years, cast your mind all the way back. Cast it back past every war you have ever heard named, back past the fall of Rome, back past the building of the pyramids, back to the very first cities of mud brick rising along warm rivers, the first written words pressed into wet clay, the very dawn of what we call history. That entire human story, it is all of it, every recorded life, fits inside the time it would take our fastest machine to make one single crossing to the nearest star, and it would arrive with no one aboard who remembered leaving. If a crew had set out on that Christmas Eve, at that record speed, aimed true at Proxima, they would not be a third of the way there when the last person who had ever seen the launch, and their children and their children's children down 260 unbroken generations, had all lived and died and turned to dust and been forgotten. So the record does not rescue us. It only sharpens the point. And here is the number that sharpens it most of all, the one worth carrying down into sleep. At its very fastest, that Christmas Eve record, the Parker Solar Probe was moving at roughly 0.06% of the speed of light. Say that to yourself slowly. Not 60%, not 6%, 0.06%. If you imagine the speed of light as a full, brimming measure, then the fastest object in all of human history has filled that measure to about 1 part in 1,500 and left the rest untouched. Everything we have ever built, every engine we have ever fired, together they have carried us to a whisper above standing still, when the standard being kept is light. The gap between our best and the cosmic limit is not a gap we are slowly closing. It is a chasm we have barely begun to notice the far side of. And even the speed of light, even that brimming, untouchable measure, minus is itself, as we have been learning all along, cosmically slow. So we are the slow, chasing the slow, and falling hopelessly behind both. There is a way to feel the true size of the distance, one that needs no spacecraft at all, only something familiar. You have sat in a car on a long, dark road at night. You know the steady, hypnotic hum of it at 100 kilometers an hour, the pace of an open highway, mile after quiet mile unspooling under the wheels. Now imagine you never stop. No fuel, no sleep, no turning back, just that same steady highway pace, held without pause, straight up and out through the roof of the sky and off toward Proxima Centauri. You would not arrive in 100 years. You would not arrive in 100,000. Driving at highway speed, without a single break, you would reach the nearest star in something like 45 billion years. That is more than 3 times the entire age of the universe. The cosmos itself, from its first flash of light until now, has not existed for even 1/3 of the time that drive would take. The star would be long dead, the sun behind you would be long dead, and still you would be driving. That is what a single light year hides inside it. When we say Proxima is a little over 4 light years away, the words are so smooth, so short, that the mind lets them slide past without protest. But unfold just one of those years into plain kilometers, and it becomes a number the mind simply refuses to hold. 1 light year is about 9.5 trillion kilometers, 9 million million, and then half as many again. And the nearest star is more than 4 of those laid end to end, something near 40 trillion kilometers of nothing, of pure and patient emptiness, between our warm little world and the next lamp along. We say the word nearest as though it were a comfort. It is not a comfort. It is the closest thing there is, and it is already past the reach of every machine we will ever plausibly build, past the reach of history itself, past the reach of the driving mind. And notice, as your thoughts loosen further, what we have quietly done here. We have not yet spoken of far things. We have not reached out to the distant galaxies, or the faint smudges of light that the great telescopes gather. We have not left the doorstep. Proxima Centauri is our next-door neighbour, the single nearest star in a sky freckled with thousands you can see and hundreds of billions you cannot. And already the arithmetic has run away from us entirely. Already the fastest object in human history is beaten by a factor of thousands. Already the honest answer to how long is longer than all of recorded time. If this is the doorstep, if this is what a single step costs, then what gently does the road beyond it look like? What happens to these numbers when we stop speaking of the nearest star and begin to speak of 1,000 stars, of the width of our own galaxy, of the galaxies past the galaxies? They do not merely grow, they do something stranger. They begin to bend and stretch and turn back upon the very notion of reaching at all minus. Because at these speeds and these distances, time itself, the steady clock you have always trusted, quietly stops keeping the promises you assumed it made. The years do not simply pile up the way they have so far, one honest year after another. Something else begins to happen to them, out there near the edge of light, something that the crews of any real starship would have to live inside, and that turns the whole question of the journey inside out. Here is the strange mercy folded inside those same equations, and it is a mercy with a blade hidden in it. The faster you travel, the more slowly your own clock ticks, as measured by everyone you have left behind. This is not a trick of tired perception. It is not the way a sleepless night seems to stretch thin, or a happy afternoon seems to fold up and vanish. It is the machinery of the universe, working exactly as it must. Time is not one single river running at one single speed for everyone. It bends, it stretches, it slows for the traveller who moves quickly, and it does so by an amount that becomes almost unbelievable as you press closer and closer to the speed of light. Consider for a moment how ordinary your own sense of time feels tonight. The clock beside you keeps its steady count, 1 second following the last, as reliable as anything you know. It has never once lied to you, and for the slow speeds of an ordinary life Clanence, a walk down a corridor, a car on a wet road, a jet crossing an ocean in the darkness, it never will. The bending is there, always, but so unimaginably small that no heartbeat, no wristwatch, no whole human life could ever notice it. Time dilation is not switched off in your bedroom. It is simply too faint to feel, because you move so gently through the world. It only wakes, only shows its true and terrible size when something approaches the speed of light, and nothing in your life ever has. Imagine, gently, a ship that could hold a steady push, the same comfortable pull you feel right now, holding you down into your bed, the ordinary weight of your own body at rest upon the earth, 1 gravity, 1 G. A ship that gathered speed at that gentle, constant rate, going a little faster with every passing second, would begin to close on the speed of light within about a year. And once it did, the clocks aboard and the clocks at home would part company, not by seconds, not by hours, by an ocean of time. At that steady 1 gravity push, a crew could reach the nearest star, Proxima Centauri, 4¼ light-years off, and feel only about 3½ years pass inside the ship. 3½ years of shared meals, of sleep and waking, of watching the same quiet walls, a single stretch of a human life. And this is where the blade turns softly in the hand, because while those 3½ years pass for them, close to 6 years pass on the earth they left. Already the 2 clocks disagree. Already home has run ahead. Now do not stop at the nearest star. Let the ship keep pushing, out past 100 stars, past 1,000, out through the flattened wheel of our own galaxiness, 100,000 light-years from edge to edge, 100 billion suns, and perhaps as many as 400 billion, wound slowly around a bright and crowded centre. To cross that wheel at the very speed of light would take 100,000 years, but the crew, held in the strange grip of time dilation, would not feel 100,000 years. Pushing at that same gentle gravity, they could cross the whole width of the Milky Way and feel only a dozen years or so slip by inside the ship. The galaxy shrinks, from their point of view, to something a single lifetime could nearly span. And then, beyond even that, Andromeda, the nearest great galaxy to our own, floats 2½ million light-years away, a soft smudge of 2.537 million light-years, drifting toward us at about 110 kilometers every second. A crew accelerating the whole way at one gravity could, in principle, reach Andromeda and step out onto its far shore, having aged only about 28 years. 28 years. A person could board that ship as a young adult and arrive, still working, still curious, at the edge of another galaxy. But here is the full weight of it, and it is worth letting settle slowly. While those 28 years passed for the travellers, more than 2 million years would have passed on the Earth. Not a lifetime, not a dynasty, not a civilization. More than 2 million years longer than there have been recognizably modern humans walking this planet at all. The travellers would arrive, and everyone they had ever known would be gone, not by generations, but by geological ages. The languages would be gone, the countries would be gone, the species itself might well be gone, or changed past all recognition. There would be no home to return to, only the memory of one, carried in a ship that had outrun time itself. So notice what has quietly happened to the question. When you asked how to reach the stars, you were asking about distance, and about speed, and about how much energy it might take. But the universe has answered you in a different currency altogether. It says yes, in a sense, you could go. Not easily, not with anything we know how to build, but in the cold arithmetic of relativity, a fast enough ship could carry a living crew across the galaxy and beyond within a single human span. And the price of that passage is not paid in fuel. It is paid in everyone you love. It is paid in the world you came from, which does not wait, which cannot wait, which ages and dies and is buried and forgotten while you sleep between the stars. To go, at these speeds, is to arrive as a kind of ghost, a visitor out of a dead age, holding a return ticket to a place that no longer exists. And even this brutal bargain, is the hopeful version. It assumes the impossible, a ship that could hold that steady push for years, drawing on energies we have no way to gather, shielded from radiation we have no way to stop, slowing itself gently down again at the far end without tearing itself to pieces. Nothing we have ever launched comes within a breath of it. Remember where we actually stand tonight. The fastest object our species has ever made touches only a fraction of 1% of the speed of light. At that speed, the nearest star is still thousands of years away, and time dilation offers us nothing at all, nothing, because we are creeping along far too slowly to bend the clock by even a whisper. So the near neighbour that keeps our hope alive is a modest one. Some 40 light-years from here sits a small, cool star called TRAPPIST-1, circled by 7 worlds near the size of the Earth, 3 of them drifting in that gentle band where water might rest liquid on the ground. It is, by the vast standards of this search, right next door. And with the fastest steady machine we have ever flown, a probe aimed at it would arrive in something like 690,000 years. Not a journey. A relay handed across thousands of civilizations, not one of whom would live to learn the answer. This is the shape the numbers take as they grow. They do not simply get larger. They cross over, at a certain point, from merely difficult into a kind of impossibility that no cleverness has yet been able to touch, where either the distance defeats you, or the energy defeats you, or time itself defeats you by dissolving the very home you are trying to bring the news back to. Every door the universe seems to open turns out to have another heavier door standing quietly behind it. And yet, even now, we have only been speaking of things that hold still and wait to be reached, stars fixed in their places, galaxies drifting slowly along. We have been assuming, all this while, that the far shore stays where it is, patient, so that a long enough journey or a fast enough ship might one day close the gap. But it does not stay where it is. The most distant reaches of the universe are not waiting for us at all. They are moving, quietly, ceaselessly, and in the one direction that changes everything. And when you begin to understand which way they are going, and how quickly the whole meaning of that word unreachable shifts beneath you into something far stranger and far more final than mere distance could ever be. Consider then what it truly means for something to move away from you. When you watch a ship slip below the horizon, or a friend walk to the far end of a long platform, you are watching motion through space. Steet is a body carrying itself from one place to another across a distance that itself holds perfectly still. The platform does not lengthen beneath their feet. The sea does not swell between the harbour and the vanishing sail. That is the only kind of departure any of us has ever known, and so it is the only kind the mind reaches for when we speak of the farthest galaxies drifting from us. But that picture, comfortable as it is quietly and completely wrong. The distant galaxies are not travelling away from us through space. Space itself is unfurling between us and them. And that single change, small as it sounds, unmakes everything you thought a distance could be. Let me say it slowly, because it is the hinge on which this whole night turns. Picture not two runners on a track, but two dots inked onto the surface of a balloon that is slowly being filled with air. Neither dot moves across the rubber. Neither one is running from the other, and yet the space of rubber between them grows and grows, and the two dots draw apart, not because either is going anywhere, but because the very fabric they are printed upon is getting larger everywhere at once. That is what the universe is doing. It is not that the galaxies are flying outward into some waiting emptiness. It is that the emptiness itself, the space between all things, is swelling in every direction, at every point, so that everything recedes from everything else, and there is no centre from which the fleeing began. You are not standing at the middle of an explosion. There is no middle. Every galaxy sees precisely what you see, the others sliding away, as though it alone were the still point of a running world, and each of them is just as wrong and just as right as you are. Now hold that picture and let the strangest consequence settle over you. Because the space between two galaxies is being created continuously, all along the vast gulf that separates them, the more space there already is, the faster that gulf can widen. A little stretching between near neighbours adds up to almost nothing. But across billions upon billions of light years, each tiny increment of stretching, summed over that unimaginable length, becomes a rate of separation so great that it outruns light itself. Beyond a certain distance, somewhere around 14 billion light years from where you lie tonight, the galaxies are receding faster than any beam of light could ever travel. And here the sleeping mind, if it is still following even faintly, lifts one drowsy objection. Did we not spend this whole evening insisting that nothing, not a ship, not a probe, not an electron, not anything at all, can ever move faster than light? Have we not just contradicted the one law we called unbreakable? We have not. And the reason we have not is the most important thing I will tell you all night, so let it arrive gently and stay. Einstein's law does not forbid all fast motion. It forbids a thing from moving through space faster than light. It sets a ceiling on how quickly any object may carry itself from one place to another across the fabric of the cosmos. But the stretching of the fabric itself obeys no such ceiling. Nothing about general relativity places a speed limit on how fast space may be created between 2 points. Those distant galaxies are not racing through the universe at forbidden speeds inside their own patch of space. They sit almost perfectly still, their nearby stars wheeling gently, their planets turning in ordinary time. It is the ground beneath them, the ground beneath us, the ground between us, that is being drawn ever wider. Not the runners breaking the rule, but the track itself lengthening faster than any runner could ever run. The law holds. It was never the kind of law we imagined. And that is the loophole the universe leaves open, a loophole that turns out to be no comfort at all, but the door onto the deepest dread of the entire night. Because here is what that expansion does to the word we have been using so freely. All evening we have said unreachable, and we have meant by it something to do with distance, a shore too far to swim to, a road too long to walk. We imagined that the far galaxies were simply very, very far away, but sitting still, waiting, so that a fast enough ship or a patient enough journey might one day close the gap. That is not the situation. The far galaxies are not waiting. With every passing second, the space between you and them is lengthening, and beyond that critical horizon, it lengthens faster than light can cross it, which means that a beam of light, a photon, the swiftest messenger reality permits, setting out from here this very night, aimed with perfect intent at one of those distant galaxies' mistiness, would never, ever arrive. Not in a billion years. Not in a trillion. Not ever. The ground it must cross is being unrolled in front of it, faster than it can travel, so that the destination retreats forever just beyond the reach of the very fastest thing that exists. Unreachable, it turns out, was never really about how far. It was about which way the far country is moving, and how quickly. And it is moving away and gathering speed. Let that word settle, gathering speed. For a long while, through most of the 20th century, astronomers assumed the expansion must be slowing down, gently braked by the gravity of all the matter tugging inward, the way a stone thrown upward is slowed by the pull of the earth. It seemed only reasonable. But when the measurements finally came, near the close of that century, they showed the opposite, and the finding was so unwelcome that those who made it checked it and rechecked it before they dared believe. The expansion is not slowing, it is accelerating. Something is pushing the galaxies apart faster and faster, as the ages pass, a faint, patient pressure woven into empty space itself, which we have named dark energy, though the name is really just a polite word for our ignorance. We do not know what it is, we know only what it does, and what it does is quietly seal the universe against itself, one galaxy at a time. So consider the shape of the sky above wherever you are lying now, the observable universe. Everything whose light has had time to reach us across the 13 8/10 billion years since the beginning stretches 93 billion light-years from edge to edge, and holds within it something on the order of 2 trillion galaxies, and stars beyond any counting, a number written as one followed by 24 zeros, a trillion suns. It is the grandest inventory imaginable, and here is the quiet cruelty folded inside it. The overwhelming majority of those galaxies are already lost to us. Of all the 2 trillion, roughly 94 in every 100 lie beyond the point of no return. Beyond what astronomers call the cosmic event horizon, a boundary drifting somewhere around 16 to 18 billion light-years out, past which not even a signal launched today at the full speed of light could ever again reach us, nor ours reach them. Fewer than one galaxy in 15 remains, even in principle, within our grasp. All the rest have already slipped, or are slipping now, behind a horizon as final as the edge of a waterfall. And it is not a settled loss, it is a loss that deepens as you breathe. Every single year, roughly 160 billion stars cross that horizon and pass forever beyond any possibility of contact, not exploding, not dying, simply carried by the swelling of the space they sit in, past the last line at which their light could ever have found us. Somewhere in the time it takes you to fall asleep tonight, whole worlds are quietly leaving the reachable universe, and they leave without a sound, and they do not come back. The cosmos is not a vast room in which we might one day wander freely. It is a room whose walls are moving outward faster than we could ever walk toward them, and whose furthest furniture is being carried, piece by piece, out through doors that then seal behind it. What looked like distance was really a kind of departure. What looked like a far shore was really a tide going out. And so the loophole in Einstein's law that space may stretch as fast as it likes gives us nothing. It does not hand us away past the speed of light. It takes the far universe and moves it permanently beyond us, and it does so precisely because there is no speed limit on the emptiness itself. The very freedom that lets space expand without restraint is the freedom that walls us in. Not a prison of bars, but a prison of growing gardens, an enclosure that keeps us not by holding us close, but by pushing everything else endlessly away. This is the turn that recontextualizes every mile and every year we have counted so far tonight. The problem was never only that the stars were far. The problem is that farness itself is not a fixed quantity to be crossed, but a living thing that grows, that accelerates, that outpaces light, and that never, once it has taken something from us, gives it back. And once you begin to feel the full weight of what that means, not for galaxies, but for the very idea of a universe we might come to know, a stranger and gentler thought begins to rise, slowly, out of the dark beneath it, for there is, folded into the very same physics that raises the wall, something that at first glance looks a great deal like a door. It is one of the strangest gifts relativity offers, and it hides in plain sight inside the very law that forbids you from ever reaching the speed of light. That law does not only slow you down, it also, quietly, slows your clock. The faster you travel, the more thinly your own time is stretched, until the hours that pass for you grow fewer and fewer against the hours that pass for everyone you left behind. And so a curious possibility begins to open in the dark. Perhaps the wall is not, after all, quite as total as it first seemed. Consider what this means for a traveller willing to accelerate steadily, sunless, not in some violent lunge, but with a gentle, unrelenting push. Imagine a ship that speeds up at exactly the rate you feel this very moment as the pull of the earth beneath you, that same soft weight holding you to your bed. Under that comfortable 1g acceleration, gathering speed year after year, a human being could reach the nearest star and step out having aged only about 3.5 years. Not 70,000, not 6,000, 3.5. And the destinations only grow more astonishing from there. That same patient push, sustained long enough, could carry a single traveller across the 2.5 million light-years to the Andromeda Galaxy in something like 28 years of their own life. A long voyage, certainly, but a voyage one person could begin as a young adult and finish while still able to marvel at the arrival. In the arithmetic of your own heartbeat, the universe suddenly seems crossable after all. This is the fragile hope. This is the loophole that has kept the dream of the stars alive in the minds of physicists who know the numbers better than anyone. The barrier was never that a single lifetime is too short for the distance. Bend time steeply enough, and a lifetime becomes enormous, vast enough to hold whole galaxies within it. The problem, it turns out, was never really the length of the journey outward. But here we must move very carefully, because this is precisely the place where the warm hope quietly cools into something else. It is tempting to hear all of this and conclude that time dilation is a kind of cheat, a secret passage that dissolves the whole cruel geometry of the cosmos. It is not. Not a cheat, but a trade, and a trade whose price is almost unbearable to say aloud. Because your clock is the only clock that slows. The universe outside your ship keeps its own steady time, and that time does not thin, does not bend, does not wait for you. While you age your 28 years crossing to Andromeda, more than 2 million years pass on the Earth behind you. Not 2 million years in some abstract ledger. 2 million years of mornings breaking over the very room where you are lying now. 2 million years of everyone you have ever known living out their small lives and vanishing, and their children after them, and every language on Earth rising and being forgotten many times over, before your ship has so much as arrived. Think for a moment of the clock inside you tonight, the slow, faithful tally your own body keeps in the beat you can feel if you rest a hand on your chest. That is the clock the traveller carries with them. It is honest. It is theirs. And it is the only thing that would survive the crossing intact. Everything else, the world, the people, the moment they belong tonight, would be spent along the way like fuel. So the door is real. But notice, gently, what kind of door it truly is. It is not a door in space, opening onto a place you might visit and come home from. It is a door in time, and it swings in one direction only. You may go outward. You may never truly return this. Not to anyone, not to anything, not to a world that still remembers your name. The traveller who reaches another galaxy does not conquer distance at all. They simply agree to be exiled from their own moment, forever. Not a journey with a homecoming waiting at the end of it, but a long farewell wearing the costume of an adventure. And once you feel that clearly, the loophole stops looking like an escape from the wall and begins to look like the wall's most subtle feature of all, the way it lets you leave precisely because it knows you can never come back. And even this one-way gift lies far, far beyond anything human hands have yet built. To push a modest arc up to the speeds that make such time-bending possible. Fast enough, say, to reach the nearest star in 50 years of Earth's own reckoning, would demand an amount of energy that is genuinely difficult to hold steady in the mind. By one estimate, and it is only an estimate, something on the order of 150 billion joules, a figure that works out at today's prices to roughly $40 billion for every single passenger aboard. Not 40 billion for the whole mission, 40 billion each. The nearest star, on the most hopeful accounting we can manage, is not merely far. It is far in a way that would swallow the treasure of nations to send even a small handful of people one single way. and so the pieces begin, slowly, to settle into a single quiet shape. Gather them together as you lie there in the dark. The infinite energy the wall demands of anything that dares to reach light itself. The stretched and mournful clocks that let you cross the void only by surrendering everything you crossed it to keep. The expanding darkness that carries most of the universe permanently out of reach, a little more of it every year. Set them side by side, and a thought arrives that is larger and stranger than any single number we have counted tonight. Perhaps the silence of the sky is not a mystery to be solved at all. Perhaps it is exactly what these laws quietly predict. For if the speed of light truly does all this, if it walls every world inside its own small neighborhood, if it turns every journey outward into a one-way exile in time, if it lets the cosmos itself widen faster than any signal can ever chase, then no civilization, however old or clever or gentle, would ever spill easily across the stars. Not because they failed, not because they destroyed themselves, but because the universe is simply built at a scale and paced at a speed that keeps its children apart. This is the possibility that has haunted the quiet edges of the question ever since we first noticed how empty the sky sounds. That the very constant we have been tracing all night long, this same soft limit that lets light take its 8 unhurried minutes to warm your upturned face, may be the deepest reason we have never once heard another voice. Not a barrier that some are simply too primitive to cross. A barrier that no one crosses, ever, anywhere, because it is woven into the shape of space and time themselves. It is a heavy thought, and yet, oddly, it is not quite a frightening one, not in the way you might expect it to be. There is something inside it that settles rather than alarms, something almost kind hiding beneath the enormity of it. And to see why that should be so, we have to take this same silence and turn it over once more, slowly, in the dark, and look at it now from the other side. Turn it over then, gently, the way you might turn a smooth grey stone you had picked up half, without thinking on some cold beach years ago, tilting it until the light finds a face of it you had never noticed. On the one side lies the loneliness we have been sitting with, the sense of a great house with 1,000 darkened rooms, and no one answering when you call down the corridor. But there is a second face to the very same stone, and it is turned away from you in the dark, and it is worth the small effort of bringing it round. Because if the slowness of light really is the reason the sky stays so quiet, then that quiet is not a verdict. It is not that we were noticed and weighed and found too small to bother with. It is not that some older, brighter company glanced in our direction across the dark and, seeing us, decided to look away. On this reading, the silence is nobody's choice at all. It is not an answer withheld. It is simply the shape of the room we happen to live in. And a silence that belongs to the architecture of space itself is a gentler thing to fall asleep beneath than a silence that means you have been ignored. Consider what the same wall does in the other direction. The barrier that keeps us from ever reaching them is precisely, exactly, the barrier that keeps them from ever reaching us. There is no fleet gathering somewhere out beyond the edge of the solar wind. There is no patient armada that has been closing the distance for 1,000 years and will arrive one ordinary Tuesday to find us unprepared. Whatever else is out there, and the numbers we have been turning over all night whisper that something somewhere in 2 trillion galaxies almost certainly is. It is held apart from you by the same soft constant that lets the light of the sun take its 8 unhurried minutes to cross the gulf and warm your face. The wall is not a prison, with us alone inside it. It is a quarantine that works both ways, and it is closed on every side, for everyone, forever. So the thing pressing at the edges of the quiet is not menace. It cannot be. Menace would have to travel, and travelling is the one thing the universe has quietly, absolutely forbidden. You may sleep tonight with the doors unlocked. Nothing that means you harm can cover the distance either. That is the kinder face of it, and it is a real face, and it is worth holding on to as we go on. But to feel the full weight of that mercy, to understand why it is so complete, so beyond appeal, minus, you have to stop imagining a single wall. There is not one barrier standing between us and the rest of creation. There is a whole nested series of them, one behind the other, and each one is, on its own, already enough. This is the thing the mind resists, and it is the thing we are going to do slowly now, in the dark, one layer at a time. Not a locked door, but a locked door behind a locked door behind a locked door, and every key you might imagine forging opens only the first of them and reveals the next. Begin with the one we have already named, distance. Even our fastest machine, the little probe that grazed the sun and set the all-time record for anything human hands have ever made. Moving at roughly 0.06 of a single % of the speed of light, would need something like 6,600 years to cross to the nearest star. Voyager, on its slower and stranger path, would need more than 73,000. That is barrier 1, and by itself it is already a wall you cannot climb inside any human lifetime, inside any human civilization, inside spans of time that swallow the whole of recorded history several times over. Most people, hearing only this, stop here and call it settled, but distance is only the outermost door. Behind it stands the second wall, and it is stranger, because it is made not of space but of energy. Suppose you did not accept 6,000 years. Suppose you wanted to go faster, much faster, to shave the crossing down to something a crew might survive awake. The universe answers with a bill that grows in a way your everyday life has never once prepared you for. On the human scale, going twice as fast costs roughly twice as much effort. You press the pedal a little harder, you burn a little more fuel, and the world obliges. But as you climb toward the speed of light, that comfortable arithmetic breaks apart. The closer you press to that final speed, the heavier your ship becomes to push mine. Not lighter, heavier its resistance swelling without limit, so that each extra sliver of speed costs more than all the speed you bought before it. And to actually touch the speed of light, not merely approach it, the sum does not become large. It becomes infinite, not a number too big to afford. A number that does not exist. This is why the wall is not an engineering problem waiting for a cleverer engine. The bill for the last step is the whole of everything, forever, and there is no economy in the cosmos that can pay it. Even a single electron, one of the lightest specks reality contains, cannot be pushed all the way there. Barrier 2, and it is not a matter of trying harder. It is a matter of the universe having drawn a line and written beside it, in a hand that cannot be argued with no further. And suppose you made peace with never reaching the line, and settled for creeping just beneath it, close enough for the third strangeness to appear. Because there is a third wall, and this one is the cruelest, and it is built out of time. Move fast enough, and time itself stops behaving as your body has always assumed it must. On the ship, if you could somehow ride at a steady, comfortable push, the same gentle pull you feel now, holding you against your bed, a traveller might reach the nearest star having aged only a few years, which sounds, at last, like a door swinging open. But ride that same push all the way to the great neighbouring galaxy of Andromeda, and the traveller would step out having aged perhaps 28 years, a single working life while behind them. Back here, more than 2 million years would have gone by. Do you feel the shape of that? You could, in principle, cross to another galaxy inside one human span. You simply could never come home. There would be no home to come to. Everyone you left, and their children, and their children's children, out to the 2 millionth generation, would be long gone to dust before your ship even arrived. You would not be a traveller returning with news. You would be a message in a bottle that outlived the ocean it was thrown into. Look at what has happened, layer by layer. Distance says you cannot get there in a lifetime. Push against distance and energy says the last step costs infinity. Push against energy and time says that even partial success severs you forever from everyone you did it for. Each wall you press against does not fall, it hands you to the next. This is the stacking, and it is why the silence is so total. It is not that alien contact is difficult, the way crossing an ocean was once difficult before we built the right ships. It is that every separate feature of physical reality, working independently, arriving at the same answer from a different direction, quietly forbids it. And your ordinary day hides all of this from you completely. In the small warm room of a human life, light is instantaneous. You touch a switch, and the far wall is lit before the thought is finished. Energy is a thing you buy in tidy amounts and never run out of the way that matters. Time is a single steady river, the whole world drifts down together. Your clock, and mine, and the clock of a person on the far side of the planet, all agreeing. Every one of those comforts is a local truth. Every one of them is a kindness the universe extends to things that stay small and slow and close to home. And every one of them quietly inverts the moment you try to leave. There is a fourth wall waiting behind these three, and it is the deepest of all, and we are almost ready to look at it, the wall that is not made of distance or energy or time, but of the ground beneath them all, of space itself refusing to hold still. For the space between the galaxies is not empty and patient. It is stretching, everywhere, all at once, carrying the most distant lights away from us faster than any ship could ever chase them, faster, in the farthest reaches, than light itself is permitted to travel folia, and doing it not by moving through space, but by making more of it, endlessly in the gaps. So that even the light we might send today, released this very second at the full and final speed, would never, not in all the time there will ever be, arrive at most of what we can see. Which means the true accounting is worse even than 3 impossible walls. And it is that fourth quiet, ever-widening barrier, the one already carrying 160 billion stars past the edge of our reach with every year that turns, that we have to lower ourselves toward now, slowly, and hold up against the light. Picture it, if the mind will hold still long enough to try, not as a wind but as a slow and even rising. The galaxies are not being scattered like dry leaves across a quiet field. The field itself is swelling. Every stretch of emptiness between one island of stars and the next is at this very moment becoming a little longer, and the further away a thing already lies, the more of that swelling gathers in the gap between you and it, and so the faster it draws away. The near neighbours drift gently. the distant ones flee, and the most distant of all flee faster than any beam of light could ever cross the widening dark that keeps opening between. Now here is the thought that ordinary living so carefully keeps from you. When we say that a far galaxy is receding faster than light, we are not saying that it is racing through space, breaking the one law that cannot be broken. Nothing moves through space faster than light. That barrier still stands unbowed exactly as Einstein left it. What is happening is stranger and softer than a race. The galaxy sits almost still in its own small corner, its own patch of space, as calm in its way as you are in your bed. It is the space between its patch and yours that is multiplying, new distance appearing everywhere at once, in every empty mile, adding and adding until the sum of it, spread across billions of light years, outruns light entirely. No rule is broken. There is simply more universe arriving in the road ahead than the traveller can ever hope to cover. And so a boundary forms, not a wall you could touch, not a wall standing in any one place, but a horizon woven quietly out of the arithmetic of expansion. Beyond roughly 14 billion light years, the reckoning tips over, and everything past that line is being carried off faster than light can approach it. Somewhere near 16 to 18 billion light years lies the cruelest edge of all, the cosmic event horizon, the true rim of the reachable. A beam of light released from here tonight at the full and final speed, aimed with perfect care, would chase whatever lay beyond that rim forever, and never close the gap. Not because the light slows, because the road keeps lengthening ahead of it, faster than it can run. Sit for a moment with what that quietly costs us. The universe we can see stretches 93 billion light years across, and it holds something close to 2 trillion galaxies, and within them a number of stars so large the tongue can scarcely shape it around a septillion, a single one followed by 24 patient zeros. And of all those galaxies, all those trillions of drifting cities of light, roughly 94 in every 100, are already lost to us. Not lost from sight, we still see their ancient light arriving faint and old, lost from reach. We could aim for them with the fastest thing physics permits, a pure ray of light, and set out this very instant, and we would never arrive. They have crossed the horizon, or they are crossing it now, and the door is closing softly behind each of them, one after another, without a sound. This is the 4th barrier then, and see now how it stacks upon the other 3. There was distance the sheer trillions of kilometers to even the nearest star. There was energy, the infinite unpayable price of the last small step to the speed of light itself. There was time, the tens of thousands of years our swiftest machines would need to cross a single gap between suns. Each one alone would be enough to keep us home. But they do not stand alone. They stand one behind the other, and behind all 3 waits this last one, the widening of space, which does not merely add another hurdle, but slowly carries the destination itself away. Distance you might, in some dream, one day cross. Energy you might, in some far century, one day gather. Time you might, with a patience beyond all patience, one day endure. But you cannot cross to a shore that is receding faster than the crossing. The other walls only say not yet, or not easily, or not in any life that you will live. This one says never, and it means the word in the strict and final sense the universe keeps for its deepest laws. And the strangeness runs deeper still, deeper than the eye ever lets on. The light from the farthest things we can see set out around 13 billion years ago, not long after the very beginning. You might think then that those things must sit 13 billion light years away, since that is how far their light has travelled to find you. But they do not. While that light crawled toward us across all those aeons, the space it had already crossed kept swelling behind it, so that the galaxies which first released it now lie some 46 billion light years off far, far beyond where their own ancient light was born. The reachable rim of everything is wider than the whole age of everything, and it is wider for one reason only, because nothing here has ever stood still, not for a single instant, not even the ground beneath it all. That is the mathematics that daily life so kindly hides from you. The floor beneath the cosmos is not a floor, it is a tide. And even if you could set every one of these things aside, even if you found some way to press a ship toward the very threshold of light and hold it there, the universe keeps one more cruelty in reserve, and it may be the quietest and the worst. Speed, near light, bends time itself. Push a crew forward under a gentle and constant pull, no fiercer than the weight you feel right now, lying still against your bed, and to those aboard the years grow strangely thin. They might reach the nearest star having aged less than 4 years. They might cross all the way to the great spiral of Andromeda, 2.5 million light years off, and step out having aged only some 28 years. A single working life, a face still recognizably their own, but behind them, at home, the clocks would not have kept that gentle pace. While those 28 years passed aboard the ship, more than 2 million years would have passed on the Earth they left. They would arrive at a far galaxy young, and they could never carry the news back to anyone who had sent them, for everyone who had ever known their names, every language they had spoken, every nation and every quiet song would be more than 2 million years into the dark. To go is to leave not only a place, but a time, and to leave a time is to leave it forever. So the true accounting, when you lay it all out gently in the dark, is not one impossible thing, but 4, folded one inside the other, and past even those a fifth that waits in the plain passage of time. Distance, energy, duration, the fleeing of the destination, and the thinning of the hours themselves. Any single one of them would be enough. Together they do not merely close the road, they unmake the very idea of a road between the stars. And you would think, holding all of that at once, that this must be the portrait of a hostile universe, a locked and grudging place, built somehow to keep every mind that ever wakes penned inside its own small yard of stars. And yet, and hold this thought loosely now, for it is where the night is slowly carrying us sunness. None of it is disorder, none of it is malice, or accident, or cruelty in any way the universe could intend. Every one of these barriers, every last impossible wall, is the same small fixed number seen from a different side. One number. Not a wall someone built to keep you out, not a gate locked against you in particular, but a single quiet fact about how quickly one thing in this universe is ever permitted to reach another. The distance to the nearest star is only that number, stretched across 4.25 years of its patient travel. The energy wall, the one that climbs toward infinity as you press a ship faster and faster, is only that same number standing at the top of the ladder, refusing to let anything with mass arrive at the very last rung. The strange folding of the hours, the way a traveller's own clock slows as they approach it, is that number again, seen now from inside the moving ship, rather than from the still ground. Even the fleeing of the far galaxies, which we have not yet fully turned over tonight, will turn out to be that number once more, measured against a universe that will not hold still. So you can let go, gently, of the idea that any of this was aimed at you. It is not malice. It is not a universe with its arms crossed. It is one small, fixed, perfectly even-handed constant, keeping exactly the same promise to every mind that has ever opened its eyes anywhere in all that darkness. And there is a strange comfort in that, if you let it settle. The wall is not personal. The wall is just true. And yet you are the descendant of a long, stubborn line of creatures who have almost never accepted a wall the first time they met one. So it should not surprise you at all that, for the better part of the last century, careful and serious people have sat with this exact problem and asked a quieter question than the impossible one. Not, how do we break the law of light, for that road is closed and always will be, but something humbler. If we cannot reach that number, can we at least lean against a decent fraction of it? Can we get a machine moving fast enough that the nearest star arrives not in tens of thousands of years, but inside a single long life, or at the very least inside the memory of a family that might still recognize the ones who left? And here, softly, is where a little hope comes back into the dark. Because the honest answer is that, on paper at least, the thing might just be possible. Consider the boldest of the old dreams, sketched out in the late 1950s by physicists who were entirely in earnest. The idea was almost comic in its bluntness. You would not burn fuel gently beneath your ship. You would ride, instead, on a rapid string of small nuclear explosions set off just behind a thick metal plate, each blast a kick, each kick pushing you a little faster, a machine that moved by detonating its way across the emptiness. They called it Project Orion, and for all its violence the arithmetic was genuinely serious. A craft like that, they reckoned, might reach something close to 1/20th of the speed of light, and at that pace the crossing to Proxima Centauri would fall to roughly 85 years. Not a weekend, not even a lifetime for the ones who set out, but a journey a child born aboard might live to finish. A wall for the first time, with a crack of daylight in it. Then, a little later, came a design that traded fire for fusion. Imagine harnessing the very reaction that lights the sun, but tamed and pointed backward as a rocket. On paper, such a ship, the one the dreamers named Daedalus, might cut the journey to the nearest star to something near 36 years. That is inside a single human life, comfortably. A person could leave in their 20s and arrive with grey coming into their hair. And if you allow yourself to reach for the most efficient fuel that physics even permits, which is antimatter, matter's mirror twin that annihilates into pure energy on contact with the ordinary stuff of the world, then the numbers grow more tempting still. Depending on how boldly you run the sums, an antimatter engine might carry a ship to Proxima in somewhere between 8 and 40 years. 8 years. To the nearest star. Spoken aloud in the dark, it sounds almost like a promise being kept. And the newest dream is perhaps the strangest and the gentlest of all, because it gives up on sending anything heavy at all. Instead of an arc, you send a whisper. You build a probe no larger and no heavier than a small chip, a gram of electronics riding on a mirrored sail thinner than a soap bubble, and back on Earth you build an enormous bank of lasers and you shine them, all together, against that tiny sail. Light itself, pushing on the sail, becomes the engine. there is no fuel aboard at all. And because the thing you are pushing weighs almost nothing, it can be driven to a fifth of the speed of light, and at that pace it would cross to Proxima Centauri in perhaps 9 to 20 years. A machine you could launch in your youth that might reach another sun before you are old. This one has a name too, Breakthrough Starshot, and unlike the others, it is not entirely a fantasy of the drawing board. People are, quietly, working on its pieces. So there it is, your small hope offered honestly. 4 different ways that the impossible softens, on paper, into the merely enormous. Hold it for a moment before the night takes it back a little, because it will take it back a little, gently, and you should see how it does so, for the taking back is itself one of the quietest and most humbling truths in all of this. Notice first what has silently happened across those 4 dreams, from the nuclear ship to the fusion ship to the gram of foil on its sail. Watch what we had to do to the traveller in order to make the star reachable. We began with a great vessel meant to carry people, a true ark with a crew who would live and perhaps die, and perhaps be born along the way. And step by step, as the journeys grew faster and more plausible, the thing we send grew smaller, from a colony to a probe to a single chip lighter than a feather. The star becomes reachable in almost exactly the measure that the thing arriving there stops being us. That last, most hopeful design, the one that gets there soonest, carries no passengers at all, no bodies, no warmth, nothing that could ever step out and stand upon another world. It is a camera and a radio and little else, a glance sent across the dark, and there is a further, quieter catch folded inside even that glance. The little sail, driven so hard by its lasers, has no way to slow down. There is nothing aboard to push against its own speed, no engine to reverse, no way to stop. So it does not arrive at the nearest star in the way you might arrive somewhere. It tears through that distant sunlight in a matter of hours, flinging back what few images it can gather as it goes, and then it is past. Still falling outward into the dark on the other side, never to return, never even to pause. A glimpse, and then gone. And whatever it manages to see, remember, must still crawl home to us at that same fixed speed of light. 4¼ years of patient travel back across the same gulf, so that the answer to a question you asked as a young person might only reach your ears when you are old, if it reaches you at all. A single conversation with the nearest star, one question and one reply, could take the better part of a human life to complete. So the hope is real, and it is also thin, and both of those things are true at once, and you do not have to decide between them tonight. Let them sit side by side. We can perhaps one distant day send the faintest thread of ourselves to the doorstep of the very nearest sun. What we almost certainly cannot do is go there ourselves, and stand and stay and come home to a world that still remembers us. The nearest star, the closest of all the countless lights above wherever you are lying now, is right at the ragged outer edge of what cleverness alone might ever touch. And every last word of that assumed the kindest possible thing about the universe. It assumed the destination waits. It assumed that the star you aim for sits patiently where you last saw it, holding still through all the long centuries of your approach, like a lamp in a window that stays lit until you arrive. For the nearest few stars, drifting slowly against the black, that is nearly true enough. But lift your gaze past them now, past the whole disk of our own galaxy, out toward the far faint smudges of light that are other galaxies entirely, and the ground itself begins to change beneath the question. Because out there, on the largest scale of all, nothing is holding still. The universe is not a fixed dark room with lamps hung at fixed distances, waiting for you to cross to them. It is something far stranger and far more restless than that. And what it is quietly doing, everywhere, in every direction, in the vast spaces between those distant lights, is about to take even the patient generosity of the speed of light and turn it into something colder than any wall we have named so far. For most of human history, we imagined the space between the stars as a simple nothing, an absence, a gap, an empty stage across which the lights were hung and the travellers might one day walk. That picture is calm and easy to hold, and it is also in the deepest possible way wrong. The emptiness is not passive. It is not merely sitting there waiting to be crossed. Ever since the beginning we call the Big Bang, some 13.8 billion years ago, that space has been doing something quietly enormous. It has been growing, not spilling outward into some larger room, for there is no larger room, but swelling from within, every stretch of it lengthening, every gap between the distant galaxies widening, gently and ceaselessly, in every direction at once. Let that settle for a moment, because it changes the whole nature of the journey. When you throw a stone across a still pond, the far bank stays where it is. But imagine now that the water itself were being made, everywhere, all along the way, so that with every stroke you swam the far bank drifted a little further off. For the stone you toss across a room, this makes no difference you could ever notice. For the nearest handful of stars, drifting slowly against the black, it makes almost none. But out among the far galaxies, across millions and then billions of light years, this slow manufacture of space adds up, and it adds up without mercy, until it overwhelms even the swiftest thing there is. Here is the part that sounds at first like a mistake. The most distant galaxies are moving away from us faster than light, faster than the very speed we have spent this whole long night calling the universe's unbreakable limit, and yet no law is being broken. This is the subtle, beautiful loophole at the heart of it. Nothing is racing through space faster than light that truly is forbidden, and it stays forbidden. It is space itself, the ground between us and them, that is expanding, and there is no rule anywhere that limits how fast new distance may appear. Add enough expanding space between 2 points, and they will recede from one another faster than any signal could ever bridge the gap, not because either is moving quickly, but because the between of them is quietly multiplying. Beyond roughly 14 billion light-years from where you lie tonight, the galaxies are already slipping away from us faster than light can close the distance, and general relativity, Einstein's own deeper theory, permits this without the slightest contradiction. And so we arrive at a boundary far colder than any wall of infinite energy. It is called the cosmic event horizon, and it sits somewhere around 16 to 18 billion light-years away. It is not a wall you crash into. It is a line beyond which the universe has in effect already said no. A beam of light launched from Earth this very night, at the full and perfect speed of light, aimed at a galaxy beyond that horizon, will never arrive. Never. Not in a billion years, not in a trillion, not in any span of time the universe will ever contain. The expanding space in between will always open faster than the light can cross it. Forever. Those galaxies are not far away in the way a distant city is far away. They are unreachable in principle, sealed off, not by our slowness, but by the shape of reality itself. When you tally what that leaves us, the number is staggering and quiet at once. The observable universe stretches some 93 billion light-years across and holds an estimated 2 trillion galaxies, and within them something on the order of 1 septillion stars. A 1 followed by 24 zeros, a count so far past imagining that the mind simply lays it down. And of all of that, all those galaxies, all those suns, roughly 94% are already forever beyond our reach. Not merely hard to get to. Impossible. Sealed behind the horizon by the expansion of space. We can still see their light, the ancient light they sent long ago when they were nearer, still crossing the gulf toward your eyes tonight. But we could never, under any physics we know, send anything of ourselves to meet them. We are looking at a photograph of a country we can never visit, and it is getting lonelier, slowly, as you lie there. This expansion is not holding steady. It is accelerating, driven by something we have named dark energy chiefly, because we needed a name for it, a faint pressure woven through empty space that pushes the great distances ever wider. And so, every single year, roughly 160 billion more stars cross that cosmic horizon and pass beyond our reach forever, one by one, quietly without a sound, like lamps being carried out of a house into a fog. They do not go dark, they simply drift to where no message of ours could ever follow. The reachable universe is shrinking gently all the time, even tonight. There is one small mercy in all of this, and I want to give it to you before the larger thought closes over it, because it is real. Not everything is fleeing. Our own galaxy is bound to its nearest companions by gravity, held close against the expansion. A small warm neighborhood that will stay together, and one great galaxy is not running away at all. Andromeda, our nearest large neighbor, some 2.5 million light-years off, is drifting toward us, falling toward us, in fact at around 110 kilometers every second, growing imperceptibly brighter across the ages. For a moment that feels like hope, a whole island of 1 trillion stars coming to us, closing the distance the universe elsewhere keeps opening. But even here, the light speed limit sets the terms, and honesty asks me to say so softly. That approach unfolds over 4 to 5 billion years, longer than the Earth has existed. And the newest reckonings, drawn in 2025 from the most careful measurements we have of how Andromeda truly moves, suggest even a direct meeting is far from certain now, something closer to a 2% chance of a real head-on collision, with the likeliest outcome a long, slow, glancing pass across timescales no human civilization could ever witness from end to end. And should the two galaxies ever merge, it would change nothing about the distances that matter to a traveller. Stars are so far apart that even a galactic collision is almost all empty space. The suns would sweep past one another and scarcely touch. The nearest star would still be years away at the speed of light. The horizon would still be sealed. The 94% would still be gone. So the tiny hope and the vast dread arrive together, hand in hand, and neither cancels the other. We are held safely in a small bright island that will not abandon us, and we are cut off, permanently, from all but the faintest edge of everything that is. And that leaves one last question waiting in the quiet, larger than any we have asked tonight. If almost the whole universe is unreachable, and always was, and always will be, then what exactly is all of it for? It is a question that arrives with no answer folded inside it, and perhaps that is the gentlest place to begin. For everything else we have turned over tonight, the universe has been quietly forthcoming. Ask it how fast light travels, and it answers with a number so exact that we long ago stopped measuring it and simply agreed to define it: 299,792,458 meters in a single second, not one more, not one less. Ask it how far away the nearest star is, and it answers, without hesitation, 4¼ years at that same unhurried speed. Ask it how much of itself lies forever beyond our reach, and it gives you a number 294 in every 100 galaxies, sealed away behind a horizon we can never cross. But ask it what all of that is for, and it says nothing. It simply keeps expanding, quietly, carrying 160 billion more stars past the edge of the reachable every year, indifferent to whether anyone is watching, indifferent to whether the question was even asked, and so we are left to answer it ourselves. That is the strange gift buried inside the silence. The cosmos will hand you the mechanism, freely and completely, but it will never hand you the meaning. The meaning is the one thing you have to bring yourself. So let us hold the two halves of it up together, one last time gently, the way you might turn a stone over in your palm before setting it down. Perhaps the sealed horizon really is a kind of loss. Perhaps it is the saddest fact in all of physics, that the universe is almost unimaginably full, brimming with 2 trillion galaxies and something close to a septillion stars, and that nearly all of it is a country whose door was locked before we were born, locked not by malice and not by accident, but by the plain arithmetic of light and distance and expanding space. Perhaps every one of those 160 billion stars slipping over the edge each year is a small bereavement, a letter that can now never be sent, a hand that can never be shaken. Perhaps the whole architecture of the heavens is a museum built too large for anyone to walk, its far galleries going dark faster than any visitor could ever hope to arrive. Or perhaps it is something else entirely. Perhaps the very same fact, seen from a slightly different angle in the dark, is not a tragedy at all, but a mercy. Consider what the alternative would have to look like. Imagine a universe small enough to cross, close enough to conquer, near enough that the light speed limit was no barrier, and the stars stood shoulder to shoulder within easy reach. That universe would not be a wonder. It would be a crowded room. Everything reachable would in time be reached. Everything conquerable would in time be conquered. And the great silence that lets you lie here tonight beneath an untroubled sky would have been filled long ago with the traffic and quarrels of whoever got there first. The slowness of light is not only the thing that keeps us in, it is also the thing that keeps everything else out. The same barrier that seals us inside our small bright island seals every other island too, each in its own quiet quarantine, so that no one is ever crowded, no one is ever overrun, and the night above your window stays exactly as still and as private as it is right now. What looks from one side like a prison wall looks from the other like the reason there is any peace at all. And notice, this is the part worth resting on misers, that both of those readings are made of precisely the same facts, not different physics, not a different universe. The very same 8 minutes and 20 seconds of sunlight, the very same 4¼ years to the nearest star, the very same horizon at 16 to 18 billion light-years, the very same infinite wall of energy standing between any traveller and the speed of light. The numbers do not change. What changes is only what you decide they mean. And that is not a weakness in the science. And it is not a failure of our understanding. It is the one place where the universe steps back and leaves the choosing to you. So let this be the small gift you carry down into sleep tonight. You are not obliged to read the cosmos as a verdict. Its vastness is not a measure of your smallness, any more than the height of a ceiling is a measure of the worth of the person standing beneath it. The universe does not know how large you are. It has no scale on which you register at all, not your body, not your years, not the whole brief history of everyone who has ever lived. And this, far from being an insult, is a kind of freedom. Because if the cosmos cannot tell you that you are small, then it cannot tell you that you do not matter. It has, in truth, no opinion of you whatsoever. Whatever meaning your life holds was never something the stars were going to grant or withhold. It is not issued from 93 billion light-years away. It is made here, at the scale you actually live at, an arm's length, a shared table, a hand held in the dark, at exactly the scale where the speed of light is more than fast enough to carry a glance from one pair of eyes to another with no delay you could ever notice. There is something almost tender in that arrangement once you let yourself see it. The universe is enormous, and you are not, and yet the two of you are built to precisely the same law. The light that took 8 minutes and 20 seconds to cross the emptiness between the sun and this planet is the same light that crosses the width of your bedroom in a handful of billionths of a second miser so quickly that, for every purpose your life will ever have, it is simply everywhere at once. On the scale of galaxies, light is agonizingly slow. On the scale of a human room, it is instant. And you live your whole life inside that second reading. The slowness that severs us from the stars never once touches the small warm world of the reachable, the world of faces and rooms, and the near at hand, where light is generous and quick and asks nothing of you at all. The cosmic speed limit is a wall only at cosmic distances. Up close, where you actually are, it is not a wall. It is a courier that never keeps you waiting. And perhaps that is the quiet correction our fear had coming. We began tonight worried, in a way, about who might reach us across that darkness. And we found patiently, star by star and number by number, that the honest answer is almost certainly no one, ever, from anywhere. No alien fleet is crossing 73,000 years of emptiness to arrive at your door. No civilization, however old or however clever, is stepping over the infinite energy wall that Einstein sketched in a patent office in 1905. The very laws that keep us home keep every possible visitor home as well. And so the frightened question we might once have asked, are we safe out here, so exposed, so alone, turns out to have a softer answer than we expected. You are not exposed. You are held. The same slowness that makes us lonely is the same slowness that makes us safe, and there is no version of the physics that gives you the one without the other. So the choice, when you finally reach it, is not really a choice between two universes. It is a choice between two ways of lying here in the same one. You can hear the 94% as a loss, all those galleries going dark, all those letters that can never be sent. Or you can hear it as the reason for the stillness. the quiet that no traffic will ever fill, the privacy that lets a single small planet keep its lamp lit through the night without fear of the dark around it. Neither reading is forced on you, neither is more scientific than the other. The facts sit there, patient and unchanging, the way facts do, and they wait to see which meaning you will lend them before you drift off. And you do not have to decide tonight. That is perhaps the kindest thing of all. The question of what the whole vastness is for is not a debt that comes due before morning. It is weighted in one form or another in temples and observatories and quiet dark rooms much like this one, for as long as there have been minds gentle enough and awake enough to ask it. And it will wait a while longer, without impatience, while you rest. The universe is in no hurry for your answer. It has, after all, been expanding for 13.8 billion years, and it will go on expanding long after this night is a forgotten thing, carrying its distant fires ever further apart with the same slow, even untroubled patience it is kept since the very beginning. You are allowed to simply lie inside that patience for a while and let the question soften at the edges, not solved, not surrendered, only set down gently the way you set down anything heavy at the end of a long day. And the oldest, plainest form of that question nicens, the one that has kept its watch in all those temples and observatories, is simply this: are we alone? You may hold it lightly now, turning it over the way you might turn a smooth stone in the dark. Perhaps we are alone. Perhaps the long quiet of the sky is exactly what it seems, and the reason no ship has ever crossed the dark to find us is that there is no one out there to build one. Or perhaps be Mises, and the physics leans, if anything, this gentler way. The quiet is not emptiness at all. Perhaps the sky is crowded, thick with warmth and thought and small lit worlds, every one of them fixed where it stands by the same slow limit that fixes us. Not the silence of an empty house, but the silence of a vast one, its rooms simply too far apart for any voice to carry. Not a cosmos that neglected to give us neighbours, but a cosmos that gave us a great many and then set every one of them beyond the reach of the fastest thing that exists. Which of these is true, you are not required to settle tonight, nor for many nights, nor perhaps ever. That choice belongs to you, and to no law of physics the numbers can tell you how far the light must travel and how long the crossing would take, but they cannot tell you how to feel about a sky that keeps its neighbours to itself. You are free to find it lonely. You are just as free to find it a kind of tenderness. The universe hands you the facts, and then with unusual grace leaves the meaning entirely in your keeping. And notice, before you let it all go soft, what a strange comfort hides inside the arithmetic. If the light itself is this slow-mo, if even that fastest of all things needs years to cross to the nearest star, and 100,000 years to cross our own single galaxy measness, then whatever else is out there is held just as gently in place as we are. No one is coming, but no one can. The same law binds the visitor and the host. Every civilization that has ever kindled a light against its own dark sky is, by the plain arithmetic of distance, kept close to home, tending its own small fire, wondering at its own silent sky. We are not uniquely stranded. We are ordinarily, universally, companionably alone, each of us local, each of us near, each of us listening. And here, at the very end, is the reframe worth carrying down into sleep. The speed of light is not a wall the universe built to keep you small. It is the thread that holds cause to effect, morning to evening, one moment gently to the next day. The reason the world arrives in an order you can live inside, rather than all at once. The same limit that makes the stars unreachable is the limit that makes the stars possible at all. That slowness you have spent the whole night measuring is not a flaw in the design. It is the design. It is the patient pace at which reality is allowed to unfold. So let the barrier be, tonight, not a prison, but a shelter. If nothing out there can easily reach you, then nothing out there can easily disturb you either. The same distance that keeps the neighbours silent keeps this small dark room and the breathing body in it wonderfully, safely apart. What the light speed limit gives you, in the end, is not exile. It is a quiet that no one can cross to break, and a place right here that is entirely and unhurriedly your own. There is no despair in that. There is only the oldest kind of awe, the kind that lowers the shoulders and softens the eyes and asks nothing further of you at all. Rest now, held in the great slow order of it, 13.8 billion years of patient light still travelling somewhere far above your roof. The silence overhead is not the universe forgetting you. It is the same vast, even law that made the light still keeping everything gently whole